Okay, I was talking about number 7 when I got cut off on the last one. This app only lets me have 15 minutes, so sorry for the abrupt cutoff. But I was talking about number 7 about the planets example. I said you could use analogy here, you could use enumerative induction, and you might even be able to use inference to the best explanation. But I was saying I think it would be better if you said that having these 6 characteristics causes life, or causes, or are necessary for life to develop, or for planets to develop. I'm sorry. So it's not really a theory, it's just basing on the 6 characteristics in stars. So I think inference the best explanation, probably not great here, for that reason, but either analogy or enumerative induction I think would work. And if we talk about analogy, let me scroll down to the analogy section of the chapter. So evaluating analogical arguments, this is on page 269. Now remember, an analogy is just a comparison, right? But an analogical argument is where you reason based on the comparison, right? And you're hearing a lot of analogical arguments if you're paying any attention to the news right now, because a lot of people are trying to compare the coronavirus pandemic to past pandemics, right? They say, oh, look at the Spanish flu of 1918, I think it was, right? It went away and it came back, and it went away and came back, and so coronavirus is going to do that too, right? Or they compare it to the plague in the Middle Ages, or they compare it to SARS or H1N1, which were more recent plagues, right? And so you see a lot of these analogical arguments happening with respect to the current situation, and people argue whether we're going to be out of lockdown soon or longer or whatever based on analogies to past pandemics. So the one thing you want to look for is exactly how many characteristics do these things have in common, right? So, the example they give here is about comparing monkeys and humans, right? And monkeys and humans are very similar, anatomically and genetically, but of course they're not exactly alike. So the more alike things are, the better an analogical argument. I don't know how these half pages got in. The more relevant the similar characteristics are, the stronger the argument, right? So if you're talking about monkeys and people with respect to heart medication, then the similarity needs to be with respect to the heart, not to the hands or the hair or anything else, right? So it should be relevant characteristics. The larger the number analogized in the premises, the stronger the argument, and the more diverse or heterogeneous the items compared, the stronger the argument, right? The larger the number of relevant dissimilarities between the items, the weaker the argument. So if there's a lot of dissimilarities, that makes the argument weaker, right? So when you're comparing two things, they're always going to be similar in some ways and they're always going to be different in some ways. So arguments from analogy have to be really scrutinized carefully to make sure there are relevant characteristics being talked about. So if we think of analogies here, right, the characteristics that are in common are these 6 characteristics, which we're not told what they are, right? But all the stars that have planets have these 6 characteristics. No stars that lack those characteristics have planets, right? So if it's an argument by analogy, it seems like it's a strong argument, right? So similarities are numerous, relevant, and absent in non-candidates, right? So for those kinds of reasons, it's a strong analogy. Same with enumerative induction. If every star that has planets, and it says, well, it doesn't say many, but it says planets have been discovered, we know now it's many, and that might be part of whether this is a strong or weak argument too, is exactly how many planets are we talking about, right? If it's one or two, or if it's one or two stars that have orbiting planets, then again, it could be a very weak argument, right? So partly we don't really know if this number is big or small, right? But the fact that all of the planets, with all the stars with planets, have these 6, and none of the stars that don't have planets have those 6, make it a strong argument. All right, and the last one, 8 people at the Army Recruiting Center were interviewed, and all of them said they believe the war is justified. Therefore, probably everyone believes the war is justified. This is an analogy. It is not analogy because they're not being compared. And it's enumerative induction. And enumerative induction, like all arguments that you see that are based on polls, are generally this kind of inductive argument. Right? And because polls, they take a sample and then they generalize from that sample to the whole population, right? So if you see a poll that says like Joe Biden is beating or leading Donald Trump in the polls for president, right? That's a conclusion that's derived from some smaller sample size. They haven't asked everyone in the country. They've asked a small sample size and they've generalized from it. And that's what enumerative induction is. So in this case, number 9, though, right? If you remember back to the things that enumerative induction should have, sample size, is it representative sample, and is it random or not, right? So we see here 8 is a very small sample, so that's not good. It's not representative because it chooses people at a specific place and time in a location designed for a specific purpose, which is related to the question being asked, right? So you're asking people at an Army recruiting center about war, right? So people who join an army or in the Army are going to probably have different views about war than maybe the general population would. So it's not a representative sample, and it's not random, right? You're not picking people randomly. You're picking people who are in this specific time and place. So not random. So it doesn't meet any of the qualities that enumerative induction should have, and so it is then a very weak argument. Okay, so hopefully that gives you a flavor of the different kinds of inductive argument and how to evaluate them. Now, you guys are doing the even-numbered problems, and again, like I said, all that you have to do in this exercise is just say whether it's strong or weak and give some reason why. So the part where you identify the kind of argument it is, you don't have to do, but feel free to. It's a good idea to start being able to identify these different kinds of inductive argument. But it is definitely a good idea to start to understand like what makes these different kinds of inductive arguments strong or weak. All right. So I'll be back with future videos on future exercises.